Okay, and welcome back. For those of you who've been on the line or those of you who've recently joined us, welcome to this Design World webinar, the latest in our Design World webinar series. You're here today for the webinar entitled Essential Steps in Selecting the Correct Hose End Fitting. My name is Miles Budimer. I'm the Senior Editor for Motion Control here at Design World. I'll be moderating today. A few housekeeping points before we get started here. This webinar will be made available afterwards at designworldonline.com and via email. So if everybody who's registered for this webinar will get a copy of the webinar sent via email. Also keep in mind that we will have a question and answer session at the end of this webinar. So at any time during the webinar, there's you can find the questions tab on your GoToWebinar panel there. And you should be able to type in questions, and we will do our best to get to as many questions as we possibly can. And then lastly, you can also tweet about this webinar right now in real time. The hashtag for this webinar is listed there on the screen, hashtag DWWebinar. And as I already mentioned, I will be the moderator for today's webinar. My name is Miles Budimer with Design World. I'm the motion control editor here. And our presenter for today's webinar will be Tim Deans and from the Gates Corporation. So let me tell you a little bit about Tim's background. Tim is the engineering project manager at Gates for the hydraulic systems engineering team. Tim holds degrees in welding manufacturing and automotive engineering. He's worked at Gates now for 8 years at the Customer Service Solutions Engineering Center. And Tim's team includes a mix of mechanical and chemical engineers who partner with other OEM manufacturers to design the most efficient leak-free systems possible. In addition to OEM engineering support, product application engineers provide tech training for Gates' associates, distributors, and OE engineering teams on proper use of Gates products. Tim has a pretty extensive background in fleet management as well, including managing teams of drivers and technicians, and enjoys sharing his knowledge to help others. He holds multiple patents for Gates Corporation as well, ranging from selective catalytic reduction, heated hose designs, to advanced systems diagnostic hardware for Gates Engineering and Services Division. And as if that isn't plenty, Tim has also authored many online courses as well, multiple articles, and looks like there's even one book that is currently in the works. So he's a pretty busy and pretty knowledgeable guy here, so we're happy to have him here with us today to educate us a little bit about selecting the correct hose end fitting. So with that, I will pass it on to you, Tim.
Thanks, Miles. We're going to talk today about some essential steps in selecting the correct hose end fitting, and this is going to cover a little bit on hydraulics as well as industrial hoses both. So Gates manufactures both types of hoses. So we're going to try our best to cover both in this same webinar. Excuse me. So some risks that are associated with not using the correct couplings. Obviously, if the coupling is not properly selected for the hose that it attaches to, you can either cut the tube of the hose, or the reinforcement of the hose is not going to be sufficient to hold the coupling on. So your coupling will come off, or it will rupture the hose. You're going to have some sort of a hose failure that will result. Leaks or spills that can require a hazmat cleanup, depending on the type of material that you're transferring through the hose, can also occur. Also, an increase in warranty claims, customer callbacks, customer satisfaction issues, and ultimately worker safety, depending on the nature of the application of the hose that you're using. So some critical considerations in selecting a safe and effective coupling are going to be the materials that the coupling is made out of needs to be selected to accommodate the fluid or media going through it, as well as meet the price for the job that needs to be done. Attachments, or how you're going to attach and hold the coupling onto the hose, is going to be another consideration. If you don't have the appropriate attachment method, it won't hold the pressure, or it will leak. Some of the construction, so there's various different types of construction, platings, all kinds of different things that come into play as far as the actual coupling itself and how it's going to perform for your particular job. The size and the thread, obviously we wouldn't want to hook a 6-inch hose to a 2-inch hose and knock it down, increasing the velocity or that sort of thing. We also want to make sure that those are going to be compatible and bolt together or lock together in a way that you're not going to have any kind of leaks. Coupling compatibility, again, not only with the hose, but with the environment that it's going to be in, or the fluid or media that is going to be transferring. Obviously, you wouldn't want to use an aluminum coupling for a sandblast media. The sand would simply deteriorate and erode the coupling. So you want to make sure that you're compatible with the media going through the hoses as well. Ease of handling. Obviously, I wouldn't want to put a 6 or an 8 bolt flange coupling that I've got to bolt together every time on the back of a service truck. I would want to use a cam lock or something that's easy for the person to attach or detach as they need to. Always use a good quality coupling as well as O-ring or sealing ring. Depending on the type of termination you've got, you're going to want to make sure that all of the components that go into that seal and keep this thing from leaking are good quality, and you're not going to have any issues. Remember that different manufacturers will make coupling components that will be interchangeable with another coupling component manufacturer, but they don't always match the same quality, so you may have issues. And then, of course, exposure, internal and external exposure, including everything from extremely hot ambient temperatures to chemicals to harsh environments for abrasion and that sort of thing. So you want to make sure that the coupling is selected to do the job and perform as it's intended to. Some of the materials that the couplings are commonly made out of, the most common being carbon steel or some sort of an alloy. Very, very common. The reason being it's inexpensive. Tooling is generally already existing, and it's a fairly simple adaptation to allow for different terminations to be made with the same tooling. You can also select a myriad of different platings that will give everything from corrosion resistance to salt spray to chemical resistance as well. And they are inexpensive. So carbon steel is very prominent. Brass, not quite as prominent. It's made for generally a lower pressure or something where you need some corrosion resistance. A lot of times for fuel lines and that sort of thing where you don't want a spark to occur as well, you can see brass. Aluminum, very lightweight, obviously, for lower pressures as well. The lightweight, ease of handling, it's not a big heavy coupling, so it's easy to put on the end of a very light transfer type hose in most applications. Stainless steel. Again, stainless steel is very, very good at chemical resistance, corrosion resistance, as well as different hoses will offer a lot of stainless steel fittings as an alternative to the carbon steel, simply so that you can get the corrosion resistance characteristics that you need. What you don't want to forget about is the O-ring has to be compatible as well. So if I've changed out a coupling that's a carbon steel and I've gone to a stainless steel because I'm running, say, a chemical through a hose, I want to make sure that I've got an O-ring that will handle that chemical as well. So select the material that's going to be the most compatible with the hose material, and keep in mind what it has to do. Excuse me. Carbon and alloy steel couplings, again, applicable in everything from low to high pressure environments. Easily the most common coupling that you're going to encounter. Different types of steel are suitable for different applications, so you're going to have some that are going to be a little bit harder. Best way to continue to think about this is going to be different bolt characteristics for the grade setting on your bolts. You obviously don't want to use a softer steel coupling for something where you're going to have end pull or side load. You want to have the appropriate coupling. And when in doubt, you can always contact the coupling manufacturer to find out what that steel is and what it's capable of. Plating as well. Carbon steel can be customized for specific applications. Again, it can be roll formed, it can be machined, it can be cut, it can be annealed, it can be worked with very easily. So that's the main driver behind why it's so prevalent. But it can also be plated with a myriad of platings that will allow you to do all kinds of different things with it as well. The content of carbon is generally what gives the carbon steel coupling the strength, toughness, and the ductility and machinability, weldability, all of the things that we love about the standard carbon steel is what makes this coupling so prevalent. Just remember that it is great when you have rust concerns, but you want to select the plating on that coupling that's going to be appropriate for what the exposure is that it's going to see. So if it's salt spray versus, say, a 32% urea ammonium nitrate solution on the back of a sprayer for agriculture or something, you're going to have to change the plating so that you can match the application. Brass couplings. Brass couplings are readily available, used in a lot of different applications for, say, an SAE 45-degree flare for fuel lines or airlines or a lot of different areas. And generally, a lot of times brass will be what we call a push lock fitting that goes into the hose. You simply push it into the hose, and the sharp serrations on the barb are pushed backwards so that they're actually going to lock in kind of like a Chinese finger trap, and you won't have to put a clamp on it. So you can put these on and up to about 300 psi of pressure. No clamps are required. The clamps will actually cut the tube of the hose because of the sharp serrations in the brass. So we don't recommend clamping unless you've checked with the manufacturer of the coupling to ensure that that clamp's not going to cut the tube of the hose that it attaches to. Brass is a moderately priced fitting. It's got a lot of adapters as well, which makes it very, very prevalent in the automotive and over the road truck market. Is where you're going to usually see brass. You're not going to see a lot of brass on expensive areas for corrosion resistance, but you will see it on some fuel lines and that sort of thing as well. Aluminum couplings. A lot of times when we say aluminum couplings, we're going to be referring to industrial hoses that they go on to. Back in the day, there were some aluminum fittings that were used on hydraulic hoses, but they've kind of gone by the wayside. Primarily where you see aluminum today is going to be in suction and transfer type hoses, back of a truck that's going to be delivering fuel, something along those lines. You're going to see aluminum couplings that are used in everything from agriculture to mobile, generally for a lighter hose that's going to be very easy to handle, and it's going to reduce the weight as well as allow for good corrosion resistance and strength characteristics for that particular application. And again, aluminum is a moderately priced coupling, fairly easy to put onto the hose and crimp or attach with bandit clamps, and meets a lot of use requirements for industrial hoses. Excuse me. Stainless steel couplings are excellent for corrosive environments such as saltwater, maritime applications, chemical exposure. They are applicable for everything from extremely high pressure hydraulic lines or say a mud system on a drill rig to the low pressure as well. So they're kind of a generic do-it-all, just like a carbon steel, only a much more expensive coupling. So you always want to use stainless sparingly. Make sure that the need warrants the additional cost. Many different grades of stainless steel are available. Most major coupling manufacturers select 316 stainless for the ferrule and the coupling, or if it's a ferrule that's attached to the coupling, that's going to give us the greatest amount of not only corrosion resistant characteristics to chemical and salt spray, but it also gives us a good solid deformation that we need when we're crimping it on for a permanently attached coupling. It's a reliable flow of the steel when it's crimped onto the hose, so we can make sure that our wall compression is going to be sufficient to keep the coupling attached to the hose at whatever pressure we rate it for. Attachments for hoses range from ferrules, which are going to be common on hydraulic fittings, or on some of your larger industrial hoses as well. Or crimp sleeves will still be permanently attached, but it will be a secondary, almost like a ferrule, but it's a simple sleeve without a locking collar mechanism on it. That can be used as well, something that you're going to collapse and compress the wall of the hose to retain the coupling onto that hose, is what the ferrule is going to do. Generally, for over 150 psi, you can expect to see a permanently attached hose of fitting of some sort, whether it's a compression sleeve or a ferrule of some sort. They're available in metal or brass, and if it's a permanently attached ferrule, you will require a crimping machine and the proper settings given to you by the coupling and the hose manufacturer to use that. Again, remember, all of these are going to work off of a wall compression calculation that is determined by the hose manufacturer that's going to be required to handle the pressure and retain that coupling at that pressure. Bandit clamp attachments are very prevalent in industrial hose, very easy to apply, inexpensive, and fit most types of low pressure hoses for suction and return lines. But again, always want to consult your hose and coupling manufacturer to make sure that you've got the appropriate bandit clamp on there, or sometimes more than one bandit clamp will be required to handle the kind of retention that you're going to need. For any more information, you can always go to the coupling manufacturer. For instance, Gates has our catalogs online, or for crimping information, always consult the electronic version at a manufacturer versus the print version, simply because print takes months to get to the printers and send out to the field, whereas the online e-crimp type systems are going to be the most up-to-date that you can get and updated regularly by engineers who develop the crimp settings. So some constructions to consider as far as the hose and the couplings. Again, it's got to be compatible with the fluid going through the hose. So if I've got a nitrile tube stock in my hose, I'm going to have great oil resistance. So I want to have a nitrile O-ring or something similar that's going to seal the coupling. If it's a CPE tube stock hose, that tells me either I've got chemical application or I may have a high temp concern. So I want to make sure that my coupling O-ring is going to have that same compatibility. So if I've got a CPE tube and I put a Biton O-ring, for instance, in the coupling, then I'm assured that I'm going to have that temperature resistance that's going to match the coupling and the hose. The coupling stem must be compatible with the hose. There's a lot of different coupling manufacturers out there with the serrations that are on the stem that are developed specifically for the correct holding compression that we need in the hoses. Some couplings are not meant for certain hoses, and those serrations are more severe or not severe enough, so they'll either be more severe and cut the tube of the hose, creating a leak, or not severe enough and won't hold the pressure and the coupling will blow off. So you always want to make sure that that stem and ferrule or compression sleeve is going to be compatible with the hose to make sure that it's going to work the way that you want it to. If the serrations in the beater stem are not correct and you do experience a hose leak, then you're going to want to contact the hose and the coupling manufacturer and let them work together to make sure that you've got the proper crimp specifications and or clamping that you need on that particular hose to work with that coupling. Some of the hose constructions that these couplings are going to have to work with, and there's a lot of these hose constructions out there, are going to be ranging from everything from a 6-spiral hydraulic hose that can handle up to 8,000 psi of pressure to a mud transfer hose, for instance, on a drill rig top drive system that could see up to 7,500 or even 15,000 psi demands if you get any kind of shock load on these systems. So again, spiral construction hose is definitely going to use a very specific coupling made uniquely and specifically for that hose. Wire braid hoses, obviously a little bit less pressure, but still with wire reinforcement are going to be a higher pressure hose. You're going to have some more deformation of the wire because it's not so much steel there. You're actually going to deform some of that wire, bite the wire is what we call it, and that's going to give you your coupling retention. So you're going to see that on everything from hydraulics to water blast hose, or some of your industrial media blasting type hoses and the like. Again, high pressure, extremely high pressure, so it's something you're going to have to be careful of, but couplings will have to be made specifically for that type of a hose. Textile reinforced hoses are a little more forgiving. A lot of your textile reinforced hoses are also not the highest pressure. Some of them are going to be around 500 psi or below. So again, this opens up the opportunity for different attachment types. So we can do a push lock fitting for air, water, or multi-purpose hose, that sort of thing, where it won't need to be clamped or crimped. But always want to make sure that your coupling manufacturer and your hose manufacturers are the same and have signed off on your attachment method. And then, of course, the helical construction. The hoses will be built with a steel wire helix or a monofilament helix built into the hose, and that keeps the hose from sucking shut under suction. So we want to make sure that we've got the coupling that's not going to cut that helix, especially if you've got a monofilament helix. If you get the improper crimp information, you can easily damage that helix and expose that opening to a leak path. Size and termination. Size is going to determine the volume of the fluid that will move through the hose. Remember, if you're taking the size of the coupling and jumping it down or up in size, you can change the characteristics sometimes of how that piece of equipment is going to work, or the predictability of the flow of that fluid going through. For instance, if you downsize on a coupling from a larger diameter hose, you can actually increase the velocity going through that, and you can erode the tube of the hose if you increase the velocity enough. Otherwise, if you increase the size of the hose or the coupling, you can slow the flow of the fluid, and you won't have a predictable handling characteristics if it's a hydraulic system, or you will not have this proper delivery of that fluid that you're transferring through that hose as it's intended to work. So the determination will be determined by the components that it hooks to. So for instance, if I've got a 4-inch cam lock on a chemical refinery and I'm filling a truck, I'm going to need to have a hose with a 4-inch cam lock that's going to attach to that. So that's going to predetermine the size of the coupling that I'm going to need to attach to that and transfer the hose. So it's generally not an issue unless you don't have the appropriate size. Determination, excuse me, to determine the best size of hose and couplings that you will need for your job, whether it be hydraulics or whether it's air or pneumatic, hydraulic, or chemicals, you can always consult the Gates.com online pressure drop calculator. That's going to tell you what a length of hose with X number of couplings, whether they be 90 straight or 45-degree couplings, what your pressure drop is going to be across that hose so that you can maintain the appropriate delivery and velocities of that fluid going through the hose. And then, of course, you can also consult a nomographic chart, be it a suction or pressure line, that will tell you what your velocities are going to be should you need to change a size up or down, and you can keep your velocities in a safe area. The appropriate thread for the couplings. Again, there's a myriad of different standards organizations out there that are going to dictate whether it's SAE, hydraulic termination, say an O-ring face seal for a John Deere tractor, or a JIC hydraulic fitting. Those threads are going to be dictated by a standard, so you can appropriately select the opposing coupling that's going to attach to that based on that same standard. To find these descriptions of pressure ratings, thread configurations, and compatibilities, you can look at the SAE standards, for instance, would be 5, 16, 17, and 18. And then to find out how they perform together, you can look at a J343 SAE standard to determine what types of tests have been done on those hose and couplings. So again, coupling compatibility is going to be determined by the manufacturer, and this is an important point to make. It's determined by the manufacturer of the coupling and the manufacturer of the hose, not by the distributor or the individual that's selling the hose. They will have to consult the manufacturer of those products to make sure that what they're selling you is an assembly that's going to work for your unique application. Couplings have to be compatible with the hose, the fluid going through the hose, as well as the external environment, as well as obviously the person that's going to be working around these hoses is going to have to make sure that they're aware of some of the inherent issues with these couplings that are unique to them. The termination sealing design has to match the component and the pressure rating. A good example of this that we run into quite frequently, especially with the increase in the oil and gas industry, is people trying to use a standard male pipe on a male pipe line pipe or API type fitting for a hammer union. The male pipe and the male pipe thread and the API thread are going to be similar enough you can screw the two together, but when you use it on a hammer union application for the oil field specifically, it'll fracture the male pipe and you'll have a coupling that will fracture and blow off and people have been killed. So you always want to make sure that the termination matches as well as the pressure that you're going to be putting through that termination to make sure that that it's a safe connection and it's going to work properly. And then again, always want to make sure that we consider the fluid or the media going through the hose. If you've got an extremely abrasive fluid or an extremely acidic fluid, you want to make sure that you either change the coupling to a stainless steel or the appropriate plating to give you the characteristics that you're looking for to make sure that that lasts as long as possible. Sealing surfaces must meet the pressure and the velocity. There's certain industrial hose couplings that will not handle high velocity or flex, so you always want to make sure that that's going to meet your application as well. And then, of course, external or ambient conditions that may corrode need to be considered as well. If it's a maritime or something that's going to be on the ocean, you're going to want to make sure you've got Coast Guard approvals and that sort of thing as well. Quality does come into play, especially on couplings that you want to last for a long time. There are some hose and couplings that are kind of a disposable we use in the industry. For instance, a lay flat type hose for a water washdown on a job site. A lot of times they get run over by cars, trucks, and they're considered almost a disposable hose. So that's something where you don't see necessarily quality being the driving factor. However, on a hydraulic system, say a 2.5-inch 5,000 psi spiral hose that's going to be propelling a ship through the water, you want to make sure that that hose is going to work properly so you don't lose power or the ability to steer. So we want to make sure that we pick the quality that's going to meet the requirement for the job without spending too much money to get what we need done. Cheap couplings can have poor plating or inconsistent plating. If you've got an inconsistent plating thickness, then you'll change the coefficient of friction, which changes the holding ability or the ability to not de-torque after it's been properly torqued. So again, that's something where a lot of manufacturers will have different plating thicknesses. You want to make sure that the plating that you have is compatible with the coupling and the coupling is compatible with whatever it's going to be attached to. It also can flake off inside of a crimped coupling if the plating is not correct and can cause some issues, especially if it's in a hydraulic system. You don't want metal shavings flying around your hydraulic system or contaminating a chemical that you're transferring through that hose, or food quality. Good quality fittings can be counted on to work every single time without worry. The standards organizations have made it such that as long as you follow the OEM or the manufacturer of the coupling and the manufacturer of the hoses recommendations for how you attach these fittings to the hose, they will work in the environment that you put them into. Some products will meet SAE or ISO minimums of the standards. Most quality manufacturers or good reputable manufacturers shoot for at least 2 or even 3 times what the standards organizations dictate, so that we can make sure that these are going to work properly every time and we're not going to have any kind of issues. So we want to make sure that we consult the design specifications that are published in the manufacturer's catalogs or on their website, or you can contact their engineering teams as well if you have any advanced or more difficult questions. So ease of handling, this is going to be more specific towards some of your industrial hoses. A lot of times we're looking at industrial hoses. If you're going to be attaching them or detaching them frequently, you want to make sure that they're that your couplings are going to be in good condition and that they're going to attach or detach the way that they should. Pick the appropriate coupling that's going to meet the pressure and the requirements for the job that you've got. And then you're going to make sure that the threaded or bolted connection, if it is a threaded or bolted connection, is recommended if the connections to remain attached for longer periods of time. So for instance, if you've got something that's going to be hooked up to a water pump over a period of a month or so as you're pumping water out of a dredge or something like that, then you're going to want to bolt that on so that it's not going to come loose when someone's not watching it. Some of the questions to ask when deciding about a coupling or a hose, as far as having the appropriate ease of handling, is going to be what are you going to be putting through the hose? What are you transferring through the hose? What volume or flow do you need? So obviously I don't want to put a 12-inch diameter hose on a system that I'm going to have to be lifting manually if a 2-inch hose will work. I want to make sure that I've got the appropriate hose for that and fitting for that particular application. What's the pressure needed? Always going to make sure that the pressure is rated is not exceeding what the pressure rating listed on the hose is. And then, of course, make sure that the fittings and the hose are both made to meet the same pressure ratings. What type of port am I going to connect to? What type of connection is going to be the easiest? It's going to be a bolt-on, or can it be hammer unions, API, camlock, and that sort of thing. And then the question to ask yourself every time that you select a hose or fitting for an application is, what is going to happen if this fails? If I pick the wrong fitting, what is going to be the issue if I have a failure? Is it going to be a spill, hazmat leak? Is someone going to be injured? And then you're going to select based on the safety factor ultimately. A quick word about the hoses on these that the fittings attach to. Forced to bend for ease of handling. Obviously, we like a nice flexible hose that's going to bend into any configuration that we want, simply because it's easier to manhandle around. Some things that people don't always consider is the higher the force to bend, the more side load that the coupling has to be able to handle. So if I've got a extremely large diameter and hard to bend hose, and I drop it off of a trailer or something along those lines where my coupling is attached, the weight and the force to bend and all of that is going to be imparted to the coupling. You can fracture the coupling stem, or you can have issues there. So force to bend does more than just make it easy to move the hose around. It also affects the coupling and how long that coupling is going to stay attached to that hose. Bend radius is a consideration as well. If I've got large couplings in a small area to put the hose into, then a tighter bend radius hose is going to allow me to be easier to bend, also not put as much stress on the side load of the couplings, but it's also going to allow me to put the appropriate size couplings on, so I won't have to jump up or down in order to meet the space constraints. Weight and abrasion resistance. Again, a lot of tanker trucks use just a standard inexpensive suction discharge hose. However, there are suction and discharge hoses out there that have got a ultra-high molecular weight polyethylene cover that have a lower friction coefficient, so they're easier to drag on the ground. They don't abrade, they don't grind themselves apart on the pavement. So sometimes those are a better selection, even though they may be a little bit more expensive. Crimp, skive, or no skive couplings. Again, skive or no skive is generally speaking of a lot of the older technologies where you'd have to cut the cover off to expose the reinforcement wire, and then if you crimped the permanently attached coupling to that, it was easier to bite into or deform that wire so that you get the coupling retention. So you still see some skive and no skive, some skive out there. Primarily, most reputable manufacturers have gone to a no skive type coupling. Simply because we want to make it as easy as possible for the person assembling that hose, and make sure that it's going to be properly installed. Diameter, always want to make sure that you choose the appropriate diameter for the volume of the fluid that you're going to be transferring through that hose. If it's too small of a diameter, you can erode the tube of the hose and it will fail prematurely. Too large of a diameter, and you'll have a slowing in the hose that's going to change the predictability of the flow of that fluid. And then, of course, there's hybrid hoses for almost every kind of use that you could imagine. High flex hoses, high pressure hoses, extremely high pressure hoses, high impulse hoses. If there's not a hose that's a ready fit for your application, contact the manufacturer they may very well have a hybrid hose that you can use that'll meet your needs. Weight, a lot of hoses, especially in industrial hoses, weight is a consideration, whether I be suspending the hose from something and transferring a fluid through it or a media through it, or whether I have to ship it. I still want to make sure that weight is something that I consider when selecting that hose as well. And then, of course, flexibility. Flexibility and force to bend very much the same in that I want a nice flexible hose, but I want a hose that's going to remain at least rigid enough that I'm not going to kink it too easily and impede the flow of that fluid. Exposure, some of the things that the hoses can be exposed to we want to consider. So internal and external. We've kind of beat the internal to death. We want to make sure that if it's a chemical, we match the chemical composition of the tube and the O-ring or the material of the coupling to whatever chemical or fluid is going to go through that. Some of the external exposures and things to consider are human exposure. By human exposure, I mean the tank truck driver who tends to leave the hose hooked up once in a while when he drives his truck away. These things happen. If that's the case, or if it's a dock hose, we want to make sure we've got the appropriate breakaway coupling on that. Those things exist because people do some stupid things sometimes. We want to make sure that we think of the human exposure. Monofilament helixes, if you've got someone who's continually running over a hose with a truck or something along those lines, the steel wire, once it's compromised past 30% can't be straightened or you're going to damage the hose, whereas a monofilament helix will bounce back automatically and it won't have to be straightened. So again, if you've got people that are going to be damaging these hoses, there's something that has generally been made to handle that kind of abuse. Excuse me. External exposure could be anything from a lot of rain, a lot of heat, a lot of ozone, a lot of different things like that. Any kind of external exposure you can think of, the hoses are going to be put into that environment. So you want to make sure that you pick the appropriate hose that's going to meet as much of that need as possible. Hazardous exposure, there's all types of chemicals used in compounding the cover of the hoses or the O-rings in the couplings that have to handle all kinds of hazardous exposure, everything from sodium hydroxide to chlorine. So you want to make sure that if it's a hazardous situation, you want to make sure you pick the appropriate hose and couplings so that you're not going to have a spill and expose someone to a problem or a spill. Environmental and fluid interactions. Again, on coupling specifically, if you've got a coupling that's constantly submerged in salt water, you're not going to want to use a carbon steel coupling. Obviously, that's an area where you'd look at a stainless steel coupling, something along those lines. Temperature and pressure. Again, generally you want to make sure that you're not only looking at the coupling, but you're looking at the O-ring or the sealing gasket that coupling uses. So never forget about the O-ring or the sealing gasket. Impulse frequency. The more that a hose, the more that a hose impulses, the more it's going to work at the hose and the coupling interface. Where that becomes important is specifically, do I choose a banded clamp or do I choose a permanently attached coupling or a bolt-on 4-bolt Boss type coupling and something along those lines. Generally speaking, a permanently attached swaged or crimped coupling is going to handle impulse frequency better than any kind of a bolt-on coupling. So, and then again, on top of the impulse frequency, we want to look at the amplitude of the waveform and basically your pressure signature to make sure that you're going to handle the worst case scenario of the amplitude of that pressure waveform. Vibration, again, if I've got a high vibration environment, you're going to be wanting something that's going to be more of a permanent attached coupling versus a bolt-on or a bandit clamp. They're going to handle vibration and the weight of the hose pulling on that coupling better than something that's going to be a bolt-on. And then, of course, the connections risk in the system. If this hose fails, what's the worst that can possibly happen? Will it injure someone, kill someone? Will it shut down my mine for 2 hours while I change this hose out? I want to make sure that we think of always the worst case scenario if this hose or coupling fails. And then, of course, installation and reliability. we want to make it as easy on ourselves as we can, but still meet all of the requirements and the needs of the actual application. So that's the presentation as we've got it as far as the actual inputs. Some things you can look at as far as further questions, if we don't address them here, are the Gates Engineering hotline that we can call at 303-744-5070, or you can email me at td1403@gates.com as well. Miles, I'll turn it back to you for questions.
Okay, sounds good. Thanks so much, Tim.
No problem.
And I think we will look at some questions here. As I mentioned at the start of the webinar, if you do have any questions, feel free to type them in here, and we will try to get to as many of them as we can here in the remaining time for our Q&A. I wanted to start off with one question, which kind of goes back to something that you said very early on in the presentation, where you looked at, I think there were maybe 7 or 8 variables that you mentioned in selecting the correct hose fitting, and I was wondering, I mean, those are all critical ones that you do have to look at and should look at, but in maybe, let's say, in the interest of time or something, if you don't have the time to consider every factor, do you think, or maybe put differently, what do you think maybe the top 2 or 3 would be that are, let's say, the most critical variables? Could you? Is it possible?
That's a good question. Yep, absolutely. That's some of the most critical ones that we're going to look at as far as the standards organization are going to be the materials that they're made out of, so that they can handle the pressure and the requirements of the hose they attach to. And then, of course, the size and the thread, that's going to determine, again, the pressure rating for the thread or that termination that's been tested by a standards organization. And then, of course, the way that it attaches to the hose, so that you can make sure it fits the hose that you're going to need to do that job. So probably the materials, the attachments, and the termination itself.
Okay. All right. So let's take some more questions here. Here's a question from Elon. I don't know if I'm saying that correctly, but he had a further question about the skive geometry or dimensions. Just if you could talk some more about those. Absolutely.
So you're going to have what we call an internal skive, which is going to be cutting away of the inside of the tube of the hose, so that you can expose, you can get the coupling in and expose enough of that of the serrations or a smooth stem. When you cut the inside of the tube, you're going to want to make sure that the wall thickness is appropriate, so that that stem can compress the wall and, if need be, deform the tube into the serrations to create the sealing that you're going to require. Or sometimes you'll even do what we call an internal expansion of that stem, so you'll actually swell the steel stem into the tube of that hose. So it depends on what the manufacturer is trying to accomplish there, but you're basically on an internal skive cutting away the tube of the hose. An external skive, on the other hand, is generally cutting of the cover so that it can accommodate for the ferrule. The ferrule may have serrations, or it may be a smooth serration ferrule, depending on whether it's a free flow, which is going to be a bubble type crimp, and it's going to flow the rubber up into a bubble, and that's going to give you your coupling retention. Or sometimes you'll skive down to the wire, or buff down to the wire, they'll call it, so that you can expose the actual wire steel reinforcement, so that you can deform that into the ferrule serrations and bite into that wire, and that's going to give you your coupling retention that's going to be required for the pressure and the needs of that hose.
Okay. All right. Let's take another question here. Here's a question from Mohammed, it looks like. Looks like he had a question about how often do hoses need to be replaced?
Mohammed's got, everybody's got that same question.
Got the same question, right? Yeah.
We
it sounds like it might be
all the time.
Case by case baby or something, right? But or maybe not.
Absolutely. The thing to keep in mind about a hose is it's, if you think about the tires on your car, in the most rudimentary thinking, your tires on your car, if you drive it every day, they're going to wear out prematurely, and you're going to replace them maybe every year. if you set that car on the side of the road for 10 years, it's going to take about 10 years for the rubber to rot off, and the tires are going to fail because the tire is simply rotted. So it's extremely variable depending on the application. Generally speaking, what we recommend is that a hose not sit on a shelf before it's sold to be used in an application for more than 2 years. At 2 years of shelf life, you have basically taken away from its useful life in the actual application or use that the hose is going to be put into. Generically speaking, a relative expectation for a hose to work, if all things are okay, it's not being abraded, crushed, or that sort of thing, 4 to 6 or 7 years is a reasonable life for a hose to be used in an actual application.
Okay. And again, that would probably vary, from application to application, depending on. Excuse me, I seem to be having a little problem with my cold and my voice here. But it would probably depend somewhat on if you're running something caustic through a hose versus just plain old water or something like that too, right?
Absolutely. Everything comes into play, whether or not you've got employees that are going to run over the hose, forget to disconnect it from a truck, whether it's going to be dragged across the floor constantly, high impulse. There's a lot of different things that can come into play. Okay.
All right. Here's maybe a more general question about couplings again, but any and I guess this is similar to that first question that I kind of asked, but are there any kind of quick tips that you can give us on how to let's say differentiate from high quality couplings and low quality couplings? I know there was one of your slides there you showed some some of Gates' couplings and some other people's couplings. So is there some way that you can kind of differentiate between those two?
Generally, if you're going to be attaching a coupling, things you'll look at are going to be things such as plating consistency and overall finish consistency. Another thing that's going to tell you almost immediately about the quality is how it attaches to the end that it's attaching to. So if I've got poor plating or poor quality on my manufacturing, it may not screw into the female portion that it has to screw into, or vice versa, the female onto the male. But you also want to make sure that it comes from someone who's going to stand behind that product and give you the technical expertise and answer your technical questions that you might have. So that's going to probably be the best way to look at it, is going to be your overall finish and the company that manufactures it and their ability to answer your questions. Okay. And of course how it performs.
Okay. Let's see if we can take a few more questions here. So it looks like we have a question here from another person named John here. He wants to know what kind of coupling and hose would you recommend for membrane filters in drinking water applications? Can you make some kind of recommendation now, or is that again kind of like a...
That one's going to be obviously that one's going to be one where I'd have a lot more questions. But I would definitely be looking at something that's going to be an FDA type hose. If it's going to be drinking water, you're obviously going to need at least an FDA tube stock, and couplings are going to meet FDA at the very least. Beyond that, that's definitely one where I would contact someone in application engineering and have them look at it a little closer.
Okay. Okay. So here's a different question now about you mentioned some of the tools that were basically out there for or actually you had talked about the importance of making sure that your hose is compatible with, let's say, the fluid going through it and the actual hose itself. Are there any tools out there that kind of help you sort through all that? Because it does seem like there's quite a few variables there that you have to keep in mind for that. So is there any, do you know of anything out there that's, that kind of makes that simpler, I guess, or simplifies that task?
Absolutely. I work for Gates, so I know our catalog. Section C of the Gates catalog is going to tell you your chemical compatibility with probably about 90% of the chemicals that are out there. and the particular tube stock of the hose. And remember, the tube stock of the hose, generally say a nitrile or Viton or something along those lines, PTFE, they're going to be similar to the material, the flexible or material that an O-ring or a seal would be made of also. So you can do a lot of work on just chemical compatibility of the tube of the hose and the seal that it attaches to, and beyond that you can contact again the engineering support, and most reputable hose coupling manufacturers are going to have some sort of a chemical compatibility chart either in their catalogs or on their website that's readily accessible.
Okay. All right. Let's see if we can take a few more questions here. How many more we've got? There's another one about, I don't know if we mentioned this in the presentation, but someone else wants to know, do you consider fatigue aspects as well? And I'm assuming they're talking about the coupling there, I guess.
Absolutely. Fatigue aspects can come from a lot of different areas. That's where if it's a high impulse, you can actually flex fatigue the hose and coupling interface. Remember, these hoses are going to have a volumetric expansion, so if you've got pressure going through this hose, the diameter of the hose is going to change in relation to that pressure. And for every action, there's going to be an equal and an opposite reaction. Industrial hoses can grow in length as much as 8%, depending on their construction. So fatigue could mean something as simple as I've got a 250 psi hose that's going to continually stretch and elongate 8% of its body length, or shrink back. So you're going to be constantly flexing that hose, kind of like a rubber band, if you will. So that's going to be one area of fatigue. Fatigue aspects could also mean if I'm suspending, say, for instance, a hose from a concrete pumping truck. If you think about the hose that's actually delivering the cement, I've got the pull of the cement friction pulling against the hose, as well as the volume of the cement going through that hose. Over time, it's going to work at that coupling interface, and it will fatigue and fail that hose coupling interface. So you absolutely want to consider any kind of fatigue characteristics, be it weight at the coupling from the hose pulling on the coupling, side load fatigue, or pressure fatigue. There's a lot of different types of fatigue that can happen. When in doubt, call an application engineer on the hotline, and we can help you pick through it.
Okay. Okay, here's one more question about, I was thinking about something earlier when you were talking about the O-rings or the sealing rings and how those are critical. Is this something that you find that, let's say, that people often forget or overlook, I guess, or something, or is that one of the things, or are there other things that, let's say, people are more prone to overlook when they're working on a project or something like that?
Absolutely. Usually over-the-counter replacement parts sales of hoses, excuse me, are where we see a lot of it. For instance, a hydraulic hose that fails, it's got an O-ring and a flange or something along those lines. They'll often replace the hose because the hose ruptures, and a lot of times they don't even replace the O-ring at all, or they'll replace it with the improper O-ring. So if you've got a high pressure, or excuse me, a high temperature application, say on a hot oil return line or something along those lines, you're going to need a high temperature O-ring as well as a high temperature tube in the hose that's going to be able to handle that and be compatible with that. Unfortunately, a lot of the places where you're buying a hose over the counter, they may not know what your application is, and they may not know to ask, why were you using a high temperature hose, and do I need to change out an O-ring? Or a lot of times they won't even ask if you need an O-ring. They'll assume that you might have a kit. So you want to make sure that you always consider whatever sealing surface it is needs to be compatible with the application and the hose.
Okay.
Excuse me.
Okay. All right. Well, good. It sounds like looks like we're coming up close to the end of the hour here. So if you do have any other questions, it looks like we've tried to get them to most of them here. And if you do, maybe we can get in maybe one more question or so. If not, then I'd like to thank Tim once again for that great and very useful presentation.
You're welcome. Thank you.
There's our contact information there, which everyone can see as well. My contact info, and probably more importantly, Tim's contact info there from Gates, and you have his phone number there as well. So if you need to contact us at all, you can do so right there. So I guess we'd like to thank everyone else for coming out and being here with us, and for those people who submitted questions as well. Hope we answered them well. And as a reminder, everybody who did register for the webinar will be getting a presentation, or getting a copy of this presentation via email. So you will have this presentation at your disposal after the webinar ends here today. So if we don't have anything else, I think we can probably wrap it up. So once again, thanks a lot, Tim, for your time and expertise today. Okay, and everyone else, thank you very much for joining us here today, and hope you found it useful and learned something, and wish everyone a good rest of the day and a good rest of the week.